Hey everybody, this is 5.5, solving rational equations. So this is us taking all the things that we've been doing to simplify fractions and rational expressions and that kind of stuff, and turning it into solving equations. Remember, when there is no equal sign, we're talking about expressions. When there is an equal sign, we're trying to solve for x or y or whatever it happens to be. So an equation with one or more rational expression, fraction, is a rational equation. This is an example of an equation to solve. Don't panic. So here is the thing. We are going to do this in as straightforward a way as we possibly can. And we are going to approach every single one of these basically the same way. You are going to do first is you are going to look at the denominators, and you are going to find the least common denominator of what you see there. In this case, it's just numbers, so there's nothing to factor. Oh, helps if I have a pen. I want to find the LCD. So the least common denominator of 2, 3, and 4 is 12. And I'm going to use that. My goal, honestly, a rational equation is no fun because it's full of fractions. So my first goal is to get rid of the fractions, and I can do that with the least common denominator. So what I'm going to do is I'm going to take each of these, every single one, and multiply it by 12. What that lets me do is clear the fractions. So 2 goes in 12 6 times, 3 goes into 12 4 times, 4 goes into 12 3 times. But you have to collect what's left. So 6, what I get is here 6x plus 4 equals 3x. Oh, that's much more pleasant, isn't it? Now you can solve that. It's just a regular old equation, right? Subtract 6x, so you can put all the variables on one side. 4 equals negative 3x, divide by negative 3. X is negative 4/3. And it's finished. That was it. Okay? The trick here to anything involving fractions like this is to clear them through. This works when you have an equal sign. Okay? All right, try another one. Take a look at it. Figure out what the least common denominator is. In this case, the least common denominator is already there. It's 20. So I am going to multiply every single part by 20, each piece individually. And then I'm going to simplify. 2 goes into 20 10 times. 20 goes into 20, they just cancel. 5 goes into 20 4 times. What's left? On this side, I have 10x plus 21 equals 4x. Okay. Works the same way, right? You know how to solve from here. You should get, well, we might as well finish it. Minus 10x. I get 21 equals negative 6x. Divide by negative 6. X equals negative, divide them both by 3, 7/2. Finished. That's all this is. It does not have to be something that causes you to pause and panic, okay? All right, let's try this one. Now here, it's got a variable in the denominator, right? So we still need the least common denominator like we were finding before. So we need everything to get included. We need the least common denominator to cover the numbers and the variables. So in this case, let's see, the least common denominator of 3 and 5 is 15, and I need an x. Okay, well, the least common denominator is 15x. You are going to do exactly what we just did. Again, you're going to multiply every single part by 15x. By 15x. And then we're going to cancel. So let's look at the first one. 5 goes into 15 3 times. X cancels in the second fraction, and 3 goes into 15 5 times. So on the first fraction, I'm left with 3 times 3 is 9, and there's an x. Plus, let's see, that's a plus sign, right? Yep. 1 times 15 is 15, equals 2 times 5 is 10x. Same idea, right? Minus the 9x. I get 15 equals x. That was not terrible, was it? we can do this. So the more of these we do, the easier it will get. You can try this one. The answer to this should be 9 over -7 equals y. Least common denominator should be 3y, right? But remember, when you do your multiplication, it is not just the things that have fractions. It's everything. So you can't forget to do that one. Okay. Let's try another one. What's the least common denominator here? Well, in this case, it's w plus 1, isn't it? I just have one of the fractions doesn't happen to have that. It doesn't change the process, not remotely. We're still going to do the same exact thing. I'm going to multiply each piece by w plus 1. I'm going to put them in parentheses to make them look right. All right, so then the first section here is just 3 times w plus 1. These guys cancel, so minus 6w. These guys cancel, equals 6. And from here, you're really just solving a plain old equation, right? So distribute 3w, I want blue, plus 3 minus 6w equals 6. All right, so I have minus 3w plus 3 equals 6, minus 3. Minus 3w equals 3, divided by -3. W equals -1. And remember, in algebra, you can always check. We should, particularly in a case with fractions, okay? Because watch what happens. Remember we talked at the beginning of talking about rational expressions about domains. Well, look at what our original fractional denominator was. It's w plus 1. If I plug -1 in there, I get -1 plus 1. That gives me 0, which means my denominator is 0. Is that okay? Nope. What that means is that there is no solution to this one. Okay, so when you have a variable denominator, and we should have done it up here too, we should have gone back in and checked to make sure our answer worked. In this case, it doesn't. And because it doesn't, it means that this equation has no solution at all. All right, let's try another. Least common denominator in this case is x plus 2. And we're going to do exactly the same thing again. Everybody gets multiplied by x plus 2. Those will cancel. So then I get 5 times x plus 2 minus 8 equals 4x. Distribute 5x plus 10 minus 8 equals 4x. Let's see, minus 5x. I'm going to combine those two. So over here I get 2 equals -x, which means -2 equals x. And then you need to stop and check. So look up. Let's look at our denominator. Our denominator was x plus 2. -2 is going to be a problem because that makes a 0, which means that this, just like the other one, has no solution. So when you have a problem that has no solution, you have two choices. You can write the empty set notation like there, or you can actually write that there's no solution. What you do not want to do is just leave this like this and hope I figure it out, okay? Because I'm not a mind reader. I would love to be. I'd be on a beach somewhere. But if you know that there's no solution to the problem, you need to say that. That needs to be clear, okay? All right, let's try another one. Oh, actually, let's talk about the process. So, process for this, just to line it out, is if there's factoring that needs to be done in the denominators, that always happens first. See, it's still the first step here in equations. Find the least common denominator, multiply everything by it, solve what's left. Check to make sure your solution works. All right, so let's try this one. Well, I don't see anything to factor, which is all right, but I do see a variable with an exponent. Well, okay. So let's see, my least common denominator here is the highest exponent variable. So it would be x squared. So just like before, I'm going to multiply every single piece by x squared. So in the first fraction, let's see, I just get x squared. In the second, that guy cancels. I get plus 3x. In the third one, I get equals 28. And now what we need to do is think back to the end of chapter 4, because I can't solve that like that, right? I need to put this into standard form. Remember that standard form was ax squared plus bx plus c equals 0, right? So 28's got to move that way to the left. When I say that way and make a hand gesture on recording, it doesn't help you. Okay, and now we need a factor. So let's see, multiply to negative 28, add to 3, that should be x plus 7, x minus 4. And now we use the 0 factor property. X plus 7 equals 0, x minus 4 equals 0, so that becomes x is negative 7. This becomes x equals 4. And now we'll pause for a second and say, like, okay, if I put either of those in my denominator, both would be fine, therefore both work. All right, here's the next one. Let's see. You try this one. This one is very similar to the last one. You should get x is equal to negative 8 and x is equal to 2. You decide whether or not both are acceptable answers. Okay, if you get stuck, go into the discussion, ask a question. All right, let's try a harder one. This one says, there's definitely some stuff to factor here, right? So let's do that. This needs to be factored. It needs the difference of squares, so p minus 3, p plus 3. So now look at the denominators. What does that mean the least common denominator is? Well, I have a p plus 3 in 2 places. I have to use that. And I have to include the p minus 3. So that is my least common denominator. The process stays the same, no matter what you're multiplying by, p plus 3. This is just where it gets hard to write on my screen. So I'll multiply a p plus 3, p minus 3. Same here. Okay, so in the first fraction here on the left, those guys cancel. I'm left with 36. In the second fraction, the p plus 3 cancels, so I got 2p times p minus 3. All right, in the last one, there's no denominator, so nothing cancels. Minus p plus 3 times p minus 3. All right, so now I have a little more work to do, right? So I have 36 over here. I'm going to get 2p squared minus 6p minus, I know that that makes a difference of squares, p squared minus 9. All right, that negative has to get distributed, so let's do that. 36 equals 2p squared minus 6p minus p squared plus 9. Okay, I'm going to move the 36 over because I can see where this is headed, right? All right, so on this side I have a 0. 2p squared, oh, I don't want yellow, minus p squared just gets me p squared minus 6p. 9 plus negative 36 gets me negative 27. Well, so now factor. Let's see what happens. I need to multiply to negative 27 and add to negative 6. So that'd be 9 and 3. P minus 9, p minus 3. Oh, no, p plus 3, sorry. Property of 0, multiplication property. I just keep calling it different things. I know. 0 property of multiplication. So I get p is 9 and p is negative 3. So now stop and check. Are both of those things okay? Well, if I put in 9 squared, that's going to be fine. If I put in negative 3, this becomes 2p over 0. So that's not cool. So negative 3 won't work, but 9 will. So in this case, there's one solution, and you need to be clear that you know that. All right. Okay, same idea here, factor. Then find the least common denominator, then do the thing that's next. So let's do that. Let's factor that second denominator. It's going to be, let's see, multiply to -6, add to -3, so x minus, or -1, pardon me, x minus 3x plus 2. Okay, so that's what that turns into. What does that make the least common denominator? That makes the least common denominator for sure x plus 2, and then I need the x minus 3. Okay, so everybody gets multiplied by that least common denominator. And if you don't need to write that all out, that's fine. But when you do it on a test, sorry. I need to know that you know how to do it. So the more work you show, the better off life is for everyone. Okay, so x minus plus 2 cancels, so I get 6, x minus 3. These guys all cancel, I get minus 20x. X plus 2 cancels, equals x times x minus 3. All right, it's not the end of the world. We can do this. So let's see, now we distribute. So we get 6x minus 18 minus 20x. Over here I get x squared minus 3x. So now to get this in standard form, everybody's got to go one way or the other. I'm going to move all this stuff to the right because I want x squared to be positive. So I'm going to get 0 equals x squared, let's see, minus 6x plus 20x plus 11x plus 20x plus 20x. Did I do that math right? Oh, no, I didn't. No. 18. This is an 18. Where I used that 20x twice, not the 18. That's where I was losing it. Like, hold on, where'd the 18 go? All right, plus 18. Plus 18. That makes more sense. Okay, now we factor. We're back to a spot we know, right? So multiplication property is 0. Let's see, multiply to 18, add to 11, that's x plus 9, x plus 2. X plus 9 equals 0. X plus 2 equals 0. X equals -9, x equals -2. Do both work? Well, let's see, 9 squared, it's 81 minus 9 minus 6, that's going to be fine. 9 and 2 is 7. -2 is not, though, because x plus 2 is, that's going to give me a 0, that's going to give me x over 0, that's bad. So that guy doesn't work, this guy does, okay? All right, one more idea in here. The last idea is sometimes we have to solve for a particular variable. So in this case, I want to solve for little m. The process that we use to get there is not vastly different from what we've done to the moment, okay? Slightly, but not a lot. The common denominator for these two fractions would be little m plus big M. So I'm going to multiply both sides by little m plus big M. It's a little harder to show with my fraction. So these on this side will cancel. Here I get v times little m plus big M equals little m over v. The problem with this is that I have little m's on both sides, right? That's an issue because I can't solve for something until it's all on the same side. So I'm going to distribute here and get rid of my parentheses, and then there's going to be a trick. Are you ready? M, or big V plus, sorry, V times little m gives me capital V, little m. That gives me capital V, capital M equals little m, little v. What I'm going to try to do is get all the little m's on one side. Okay, sounds insane. This is a really hard one to see, I think. I should make that up a little bit. All right, so I'm going to change color and move up here. So on the left, I have capital V, capital M. On the right, I have little m, v minus capital V, little m. Do you see a common term? I do. It's a little m, right? So factor out the little m. V minus capital V. Now, like if I had something that looked like 4 equals x times 3. To get rid of the 3, I would just divide through by it, right? So I'm going to divide both sides by V minus capital V. And that's going to be my answer. So I get Vm over little v minus big V equals little m. The more you watch it, the more you'll be able to do it. Okay, let's try one more of those. I want to solve for x. Same process. Least common denominator is going to be x plus d. So multiply both sides by x plus d. Just gets rid of my fractions. So over here I got y times x plus d. Here these guys cancel. Ax plus b. I'm going to distribute to get rid of the parentheses, so I get yx plus yd equals ax plus b. Now I'm going to get all the x's on one side, that thing I want to solve for. And I'm going to get everything else out of my way. So I'm going to move yx to the right. So I've got yd over here equals ax minus yx plus b. And I'm going to move b to the other side. So I got yd minus b equals ax minus yx. Now on the right, I have a common term. It's an x, right? Which is perfect. That's exactly what I was trying to do. Factor out the x. A minus y is left. Divide both sides by a minus y. Okay, so I'm left with what's left is not pretty, but it doesn't have to be as long as I solved for what I needed to solve for, which was x. And it's finished. Okay, so the process here is always multiply both sides by the denominator, the common denominator, and then aim to get the thing you're trying to solve for all on one side so you can factor it out like a common term. That's it. So this is the end of 5.5. I will see you in the modules.